In this video, we're going to look at the learning target. I can graph a quadratic equation in all three forms. So we've kind of talked about graphing in vertex form, graphing in intercept form, graphing in standard form. But this video is just kind of be a run through of each form. And the first thing we're going to talk about is just the different notes on each of the forms. So if you need to stop the video to write down these notes first, you can. I was going to kind of run through in general what we need to know about all three forms. So with vertex form, remember we use our transformations when graphing vertex form. So our horizontal shift and our vertical shift will tell us where the vertex is. And then once we have the vertex, we can use A to find the rest of the parabola using the stretch or compression that we're given. Looking at intercept form then, remember that the P and the Q, the numbers inside of the parentheses will give us our x-intercepts, but it's the opposite values, okay? Remember, it's the opposite values because those are the values that give us zeros, right? That make the function equal to 0, so it's always the opposites there. The axis of symmetry then will fall in the middle, and then we just plug the axis of symmetry back in to find our vertex, and then once again we end by using our vertical stretch or compress. And then if we have standard form, the equation that we need to remember is that the axis of symmetry equals negative b or opposite of b over 2a. And then we plug that axis of symmetry in to find the y value. And then once again, we always end by using our vertical stretch compression. Now, another thing you might want to do that may be helpful for you is when you look at these three forms, one of the things that's tricky for students is recognizing what type of form they're given. You might want to think about what stands out to you in each form. So for example, when I look at vertex form, I notice that there's only one x, right? There's an x here, and that's the only x in the form. When I look at this guy, I notice there's two x's and two x's, so vertex form only has one x. When I look at intercept form, there's always a parentheses, right? But there's no squares, right? There's no exponent in it, so intercept form has no exponent. And then lastly, standard form will have an x squared and an x term, always in that form, okay? So kind of just picking out how the different forms look. All right, let's get into our actual examples here. So when I look at number 1, I have y equals negative 1/2 x minus 4 squared plus 5. And once again, I want to start with these shifts. They're going to tell me where the vertex is. So I'm going to go right 4, up 5. So over 4 to the right, up 5. That's my vertex point. Once I have the vertex, I'm then going to use my stretch. So it's negative 1/2. When I go over 1, I'm going to go down 1/2. Over 1, down 1/2. Then when I go over 2, normally 2 squared would give me 4, but I'm multiplying by negative 1/2, and 4 times the negative 1/2 is negative 2. So now when I go over 2, I'm going to go down 2, over 2, down 2. I'm going to get a parabola that looks like this. Okay, and then once again, just remember, you draw your axis of symmetry, cutting the parabola in half down the middle. Okay, so that one was graphing vertex form. The second one here is an intercept form. Okay, so I have y equals 1/3 x minus 2 x plus 4. And once again, this negative 2 and positive 4 are going to tell me where the x-intercepts are on my graph, and it's the opposite. So if I have x minus 2, that really means I have an x-intercept at 2. And then if this is positive 4, that really means I have an x-intercept at negative 4. And once again, the reason why we're getting the opposite numbers is because if I plug in these numbers, okay, so think I take this 2 and plug it in, well, 2 minus 2 is 0, and 0 times anything else is 0. So it's giving me the zeros of the function. Then, once I have my x-intercepts, I remember that the axis of symmetry is in the middle. So the middle of 2 and negative 4 is at negative 1. Okay, so I'm going to draw a dashed line at negative 1. That's my axis of symmetry. And then once I know my axis of symmetry, I know the vertex has to fall on this line. So I can just take negative 1 and plug it into the function. So I'm just going to write negative 1 in for the x's. Okay, so both x's we're going to plug in a negative 1. And then we just evaluate this to figure out where we're actually at with the vertex. So if we do this, I'm going to get 1/3 times -1 minus 2, well, that's just -3. And then if I take -1 plus 4, well, that's +3. And then I just want to multiply these together. So 3 times -3 is -9. -9 times a third, well, if you take -9 times a third, that's -9/3. And -9 divided by 3 is -3. So on my axis of symmetry, I know the y coordinate is -3. So I'm going to go down 1, 2, 3, and that is where I'm going to put the vertex. Okay. And then lastly, because I need 5 points, I always end with my vertical stretch or compress. So the A value does the same thing in every form. So it's 1/3. So when I go over 1, I'm going to go up a third, over 1, up a third. Okay, that gives me then the 5 points, and I can draw the axis, or I can draw the parabola, excuse me, through those 5 points. All right, and then the last form, once again, is standard form. So this is where we need to remember the opposite of b over 2a. So the way it works, the standard form, you have 3 coefficients, a, b, and c. B is the middle one. So we're going to take the opposite of +8, which is -8, and then we're going to divide by 2 times whatever the a value is. So that's 2 times 2. Well, that's going to give us -8 over 4, and -8 divided by 4 is -2. Okay, so that gives me the axis of symmetry, or the x coordinate of my vertex. To find the y coordinate of the vertex, then, I have to take the -2 and simply just plug it back into the function. So the y coordinate is going to be equal to 2 times -2 squared plus 8 times -2 plus 3. And then I have to simplify this. So -2 squared is 4, and 4 times 2 is 8. -2 times 8 is -16, and then I'm adding 3 to that. Well, 8 minus 16 is -8, and then if I add 3, I get -5. So the y coordinate is -5. So I just plot -2, 5, and that's my vertex. Once I have the vertex, I then just use the vertical stretch. And in this case, or I'm sorry, I went up 5. This is a -5, excuse me. It should be over 2, down 5. 1, 2, 3, 4, 5. So not this point. Apologize, I missed the negative. So this is the vertex. And then from the vertex, we end with the vertical stretch. We're ending by using the A, which is a 2. So I'm going to go over 1, up 2. Over 1, up 2. And when I go over 2, normally 2 squared is 4, but I'm multiplying by 2, so now I have to double that. I really have to go up 8. So it's going to go over 2, and then 2, 4, 6, 8. Then that mirrors to the other side. So we get a parabola that looks like this. And then the axis of symmetry cuts down the middle. Okay. So those are just some examples of graphing all 3 forms. You got vertex form, which is your transformations. You got intercept form that tells you your x-intercepts. And then you have standard form, where you got to remember it's the opposite of b over 2a to give you the axis of